In this video, we will talk about the derivatives. Learning objectives: find the derivative of a function. History: Isaac Newton and Gottfried Leibniz are widely credited with modern differentiation and derivatives. In the 17th century, they developed the fundamental theorem of calculus. This linked differentiation and integration in ways that are altered area and volume computation methodologies. Newton's work, on the other hand, would not have been conceivable without Isaac Barrow's early invention of the derivative in the 16th century. Types of derivatives. The first-order derivative shows whether the function is going up or down, so they show which way the function is going. The first derivative, also known as the first-order derivative, is a rate of change that occurs instantly. The slope of the tangent line can also be used to anticipate it. Second-order derivatives are used to figure out what the graph of a given function looks like. Concavity can be used to classify the functions. The concavity of a graph function can be divided into two categories: concave up and concave down. Differentiation is the process of determining the derivative, and anti-differentiation is the inverse process. That is the notation of the derivative. Rules. The first one is constant rule. The derivative of constant is 0. If y is constant, then the slope of the graph is 0. Example, f of fx is equals to 8. So 8 is a constant, then means 0. Number 2, the power rule states that if n is any real number, then the derivative is d over dx times the quantity of x raised to n is equals to nx raised to n minus 1. Example, y is equals to x raised to 4. To find the derivative, use the notation y over 1 is equals to, use the power rule, that is 4x, 4 minus 1 is 3, that is 4x cubed. Sum and difference rule. The sum and difference rule for derivative states that if x and gx are both differentiable functions, then we use the rule below. That is the example. Y is equals to x raised to 4 plus 3x raised to 3 minus 5x plus 3. So, we use the notation is equals to 4x cubed plus 9x squared minus 5. The constant multiple rule states that if c is a constant and if x is a differentiable function, then we use the below. That is the example. The product rule. The rule states that if fx and gx are both differentiable function, then the derivative of their product also exists. That is the example. The quotient rule states that if fx and gx are both differentiable functions and gx does not equal to 0, then the derivative of a quotient also exists. Chain rule. The chain rule states that if fx and gx are both differentiable functions and the composite function defined as f is equals to f quantity of gx, then f is differentiable and f is given by the product. Negative integer power. Power rule for negative integers: use the derivative quotient to prove the power rule for negative integers. That is, dx is equals to negative mx dr minus m minus 1, where m is a positive integer.